Taylor series. Right. Taylor was a really smart guy. Okay, I'm gonna write out. We've been working the last couple days with the power series, right? There's the power series, correct? That we've been working with. We write that out. So I'm going to expand this series out. Oh, that should be a series. So there's the power series, the general statement on what a power series is, right? We can define functions with these power series. It just depends on what the sequence is and what they're centered at, right? Does this look very familiar? No?
Yeah.
Yes. What if I were to write this? Right, remember Taylor series, Taylor polynomial is an approximation, right, of f. What's this? So the first term is f at c, right, what we're centered at. What's the second term? Factorial. What's the second term? Third, you see the pattern developing, right? You notice a similarity. What do we have here? Are those the same? Yep. And all we have is the sequence is just defined. This sequence A sub n is the derivatives of f. Okay, that's all a Taylor series really adds to a power series. And so a lot of the calculations you've been studying for power series are still going to work, like the radius of convergence with the ratio. Okay. But keep in mind that these are very related. Now, can you write the Taylor polynomial as a Taylor series? I wrote, okay, so x minus c to the n to be the same, right? What are these going to become?
F of x, so no, f prime. The nth derivative of f of x.
At what?
0.
C.
Oh, I see.
The nth derivative of f, so the zeroth derivative at c over 0 factorial. The first derivative at c over the first factorial. Second derivative at c over the second factorial. See how the pattern develops there, okay? So it's not a whole lot different than what you've had, okay? So let's write one Taylor series out. And then I think you'll probably be okay with that. Just the pattern I noticed with a lot of you, you're forgetting your factorials on the bottom. Don't forget that, okay? So now with the Taylor series or polynomial, all you have to remember, you can remember the series notation here, and that's it. Everything else can follow from there. So let's calculate a Taylor series for x to the negative third. We're centered at 1, just to make it more difficult. What's the centered at 0 called? The Maclaurin series. Yeah. So. Okay, what is f at 1? Remember, this is 1 over x cubed. So it's just 1. Okay, now what's f prime of x? Negative 3 x to the negative 4. Yeah. Yeah, don't go stupid. These are easy derivatives. Okay. Oh, Taylor series, pros. No. And then f prime at 1 is negative 3. And we can do f prime, f double prime is 12 x to the negative 5th, right? So f double prime at 1 is 12. Seeing a pattern here. The coefficient's the only thing that really matters in this one. Big part of these is noticing patterns. We do f triple prime, negative 60 x to the negative 6th. So at 1 it should be negative 60, right? So what's our Taylor series? 1 minus 3 x minus 1. If you want to be consistent, you can put a 1 factorial at the bottom. That's 1. I got it. Squared. And that's 2 factorial, right? And you can go on, right? There's our series. Can you write it in series notation now? Well, it's alternating, right? We want to start at 0 or at 1? Okay, so it's alternating. That's 1.
Oh,
The next term is negative 1 to the 1, which is negative.
oh, because you have to.
Yeah. How am I going to generate these numbers? Okay, over n factorial, right? And how do I generate x minus 1 to the n? All I need to generate is this number here. Times 3, times 4, times 5.
So.
Okay. So, third term. So
We're gonna need a bigger one.
can you do it
We're gonna need a big fraction.
using exponents? Like 2 to the n minus 1. Okay, that would be, no, that wouldn't work, because that would be 2 to the n is 2 to the first is 2 minus 1, you do 2 to the n plus 1, but that's not here. Here's what the book has. The book definitely has something more than that. N plus 2, n plus 1. And then that one's hard to come up with. It's a quadratic because notice you're multiplied by 3, right? Multiply by 4, multiply by 5. So that tells you it's a quadratic, which is what this is, right? The question is, which one? Any advice on that one off the top of my head?
It's still on. It's still listed.
The book has, actually it's 2 of them. I mixed them up. Okay, that's one of the ones the book has. With the 2 at the bottom, because they actually divide it. This would be 3, this would be 6, this would be 10. You divide these out.
Yeah.
Okay, we weren't dividing them out. So the series we were trying to generate was this one. N plus 1, N plus 2 by 12. That. So, well, there you go, you're generating a Taylor series. More than likely, you're gonna be asked this, maybe, probably not. All right, so example 2, basically is, what is the expansion of sine and cosine? Okay, these are the ones that we need to memorize. So, this is how I suggest you memorize these. Forego the series notation and just remember this. Cosine x, guess what? Check this out. This is what's really cool. What's the derivative of sine? That's the cosine. Now, can we simplify this? Because there's a 3 factorial and a 3 here, right? So So, there you go. Do you need to memorize cosine? No, you don't, because you know the derivative of sine. Okay, that's why these, again, they work really neatly because they still follow our derivatives and integrals term by term. Okay, so here's the derivative directly, and then you simplify it. Remember, cosine is even, sine is an odd. Even an odd function. Okay. The last one, just that I want to talk to you about today is b. This is another one of those very popular ones. Exactly what it is. Now, simplifying that mess is a different matter. Right? Copy dot flip, you can kind of mess with it a little bit, but I think B starts with 1. Yeah.
What? Silence?
There's E. Yeah, two factor equals 2, so that's right. You can write two factor equals. All right,
Therefore,
We're good
I'll still be.
for the day. We'll write cards for all these Tuesday. There's 7 or 8 of them. Okay. If you want to start studying for your test, page 599.
If you got Google Classroom, the assignment's posted.
If not, here it is. Okay. Oh my gosh. Yeah,
Did you kind of dig head?
I didn't write it on there because I had it until yesterday.
No money.
Wednesday.
The last one we did was pretty easy.
No money for.
If you need it, here it is,
Substitute for response.
right there.
The little pointy part, bottom.
Oh.
So like, your mom has 2 arches, the point at the bottom, the point at the bottom. Yeah.
Oh, I'll put it in. Okay.
So, Mr. Arthur, can we